Hey guys, welcome to your math notes for 4.2. So here's how this works. I'm going to be showing you guys a video, and you guys can see my paper right here. It's over like on the top of here. And I'm going to be writing down notes, and then you guys are going to also be taking notes in your notebook. So go get your notebook, get your colored pencils. You can pause, rewind this video as much as you want as we start going through it. So I'm probably going to be facing this way most of the time, but as we start working on things, I'll make sure to talk to you guys. Alright, so are you guys ready? Hopefully you got your stuff and we're set to go. So what we're going to be talking about is 4.2, and you can label it horizontal and vertical lines. Now, horizontal and vertical lines. So when we talk about these things, first of all, we need to talk about horizontal and vertical. Hopefully you remember what those words mean from previous math. Horizontal, I'm just going to put an H. Horizontal means that the lines go horizontally, like the horizon, and vertical lines means that they go up and down. So hopefully you guys can remember those things from last year or previous times. So what we're talking about when we talk about horizontal and vertical lines is on a graph. So what we're going to do is we're just going to go back to the basics. So if we had something like x equals 3, we would make a number line and we would say, oh yeah, 3 is right here and this is where x equals 3. Well, with our horizontal and vertical lines, what happens is now we're going to place that answer into a coordinate grid. So as I'm drawing this coordinate grid, I'm going to be really careful to make sure that I'm on my grid paper. So the reason we have you guys have grid paper notebooks is this is part of the reason. So try to make sure that you guys are hitting those lines. And then I'm going to find where x equals 3. So which number line is the x number line? You are correct. It is this one right here. So there's my x number line. Which one is the y number line? Obviously it's the other one. Okay, so now I've got x and y. Here's some color enhancing opportunities for you. So if I find where x equals 3, here is x equals 1, 2, 3. It's right here. And this is where I would say, oh yeah, x equals 3. But the question that I have for you is, where else on this graph does x equal 3? You are maybe right. I don't know. You're watching a video, so I'm hoping you're right. But x equals 3, we can have a point right here where x equals 3. Because if you think about this here, we have x, this point right here is going to be 3 and then 1. So our x value is a 3. We also have a point right here where x equals 3. So that would be 3 would be our x value. So x and y. So x would be 3 and then y would be 1, 2, 3, 4. 3, 4. So pretty much anywhere in this vertical line, we have x equaling 3. Pretty sweet deal, right? Well, if we think about the horizontal line then, you might be already thinking in your brain, might be already like spinning, what would be the horizontal then? So if I said this point, we'll do this point right here. What's this point right here? So we have a point of negative 1, 2, 3, negative 1, 2, 3. So negative 3, negative 3. So if you make that point. And then if I do a horizontal line, that means that my line goes this way, right? So if I start thinking of these points, here's another point, 1, 2, 3. So it's 0, negative 3. This point over here is 1, 2, 3, 4. 4, negative 3. And if I notice in my equation, or in my plots of y and x, my x changes, but my y is always negative 3. So in this case, y equals negative 3. So there's two equations that we have from all of this information. So for a vertical line, we are going to have a equation that says x equals some number. For a horizontal line, we are going to have y equaling some number. So I know how much you guys love Dustmouse, and I know you guys are a big fan of it. So I'm going to do a problem here, and we're going to take a look at why knowing horizontal and vertical lines can be useful in algebra. Okay, so let's say I'm going on vacation and I have $900 in my bank account. So here's my bank, $900, very exciting. In this $900 bank account, I am going to have $300, at least $300 in order to keep my bank account going. So $300 at least. And then because if I go lower than $300, then I have to pay a fee, which is really annoying. It happens. So every morning on vacation, I go to the bank and I take $50 out. How many days before I run out of money? Okay, so I'm going to say every day $50 out per day. So to get the problem started, what I'm going to do is I'm going to first make my algebraic equation. So if y is how much money I have, y equals my total money, and x equals my days, what's my equation? So, what do you think? I start with my total, and I start with my $900. So am I going to add money in or take money out? I should add money in, or take money out. So I'm taking out $50 per day. Okay, so everyone's got that equation, I hope. Write it down in your notebook, but now what we're going to do is we're going to flip over to decimals. So I'm going to change my screen here to my decimals graphing calculator. And so now what I can do is I can put in y equals, I'm getting really close to the screen now, y equals $900, and I'm going to take out my $50 per day. Alright, so now I've got this graph. I don't see anything here, so I'm going to zoom out a little bit, and what a crazy looking graph, but alright, let's just change this here. I'm going to change my x-axis. I don't really care about before I left on vacation, so I'll just start with -5, and maybe I'll go like 10 days in. Nope, I cannot do that one. Let's try -5 to, oh man, 50 days in? Oh, that looks pretty good. I could even change it to like a 30 days in. That looks like it might be a little bit better. So there's 30 days in. In my y-axis, well, I don't really care if I go negative numbers, so I'm just going to put a -5 again to make that a little bit easier to see. And then I want to go all the way up to my $300, because that's where I start, right? No. Thank goodness, Miss Hasselbauer. I'll put in 1,000 so I can see exactly where that 900 is. Okay, so now I've got this nice graph. And as you guys can see, as I'm going through my days, I'm starting to spend money. Well, now knowing this horizontal and vertical axis thing, I can say, well, what happens when I get to $300? What day is that going to be on? So what I'm going to do is $300. So my total has to be $300. So y equals 300. And all of a sudden, I have this amazing line that tells me the intersection of where my bank account money, the red line, hits this $300, the blue line. And so if I look, what day is it going to happen? Well, what does x equal there? It equals 12. So it's on day 12. Super useful. So then I can go back and be like, yeah, it's on day 12. So knowing how to graph these horizontal and vertical lines, so nice. It's such a good deal. And so for some of your practice problems, you're going to have to decipher, like, when is it a horizontal, when is it a vertical, thinking about the x and the y. And we'll talk more about it in class. We will answer all your questions, but make sure you have all these notes written down. In your notes, if you would like to, let me go back really quick to my notes here. And I'm going to make a quick little sketch of what we just did as well in my notes. So here's my y and here's my x. My y is my total money, and my x is my days. So here's my y. And then I just am going to make a sketch. So this was at $900, and this was at 0, and this was day 0, and I think I went up to day 20. Okay, so I'm going to put in with my color a 300 line. So this is going to be y equals $300, right? Because my y is my money. So if y equals $300, and when it equals $300, oh, what a beautiful point. It's going to be 12,300. And so this is my x, this is my y, this is my days, and this is my dollars. Man, pretty awesome. All right, we'll see you guys in class. Have a great MEA. Enjoy the notes.